Good evening. This is Naz from NB Network Lessons. Hope everyone is doing okay and safe. My today's topic of discussion is the continuation of source transformation. This is going to be part 3, and we're going to show you some observations which are really handy when you're actually doing the source transformation, subsequently simplifying the circuits. So without any further ado, let's go ahead and take a look at it, what the observations are. And these are important observations which you will use when you are doing source transformation and trying to simplify a circuit. So let's say we have V sub S, okay? And then we have a resistor, okay? And then we have a terminal right here, terminal A, terminal B, okay? Now this is what we started off with, okay? But what if there is a resistor in between right here, okay? Let's call this R1 and call this R2. Now let me ask you this, from perspective of whatever is connected to these two terminals, it could be a circuit board for TV, it could be a DC motor, it could be some sort of electronic device which is connected right here, right? So my question to you is that can we go ahead and what is the role this resistor is playing from perspective of whatever is connected over here, okay? Not from the overall perspective, but what this electronic device sees. Let me ask you this. As of right now, what we have is that we only care about the voltage device in series with the resistance R1 for voltage drop. So the voltage over here is same as voltage across these two terminals, right? You have to agree with that. So then I can easily ignore that R2 in my diagram because I don't really need it from perspective of this device which is connected, because this device, when looking towards the terminal A and terminal B, it's looking for the voltage drop across this R1, all right? And since we have the same voltage drop right here, from electronic device perspective, we can simply ignore this R2. I'm not saying that the R2 is not important. What I'm saying is that from our perspective, for simplifying the circuit, we can ignore that. So then, basically we can just write just like this right here, plus minus, and then you have A and B, and then this is V sub S, and this is R1, okay? Now let's look at another scenario. Let's say you have this current source, right? You have I sub S, okay? And then you have a resistor right here. This is the normal setup which we showed you earlier in source transformation part 1, okay? Let's call this R1, okay? Let me ask you this. And same thing, we have some sort of electronic device connected to terminals A and terminal B, right? So what if I ask you that I inject a resistor right here, okay? And we call this R2. Is it gonna make any difference for this device? Because this device is looking at terminal A and terminal B, all right? If you look carefully right here, this I sub S current is gonna flow right here. Same current is gonna go right here, all right? So we're gonna have same basically voltage drop right here. So from this device's perspective, if I take this out, this R2 out, does it make any difference? I don't know. It doesn't make any difference from this electronic device. So I can just basically draw this circuit just like, I sub S, and then you've got R of 1, and then you have terminal A and terminal B, okay? So this is what this electronic device from this electronic device's perspective, this resistor right here, I'm not saying again that it's not important, but we can simplify our circuit because we only care about what we see on these two terminals, and we see the same thing on these terminals with or without this resistor. Same thing over here. We see the same thing on terminal A and B with or without this resistor. So that's an observation which we will use further down the line when we solve the problems. So for now, take care of yourself. If you like the contents, go ahead and give me a like. I'll come back and hopefully solve a problem which will clarify any misconceptions. Thank you so much for watching. Have a wonderful day.